Hello guys, welcome to my channel. In this video I will explain the basis of linear regression in Python. Okay, now I talked of machine learning having the following broad categories. Number one is the supervised learning. We have unsupervised learning, and last is the reinforcement learning. I'm gonna look at, let's say, one algorithm in supervised learning and one algorithm in unsupervised learning. Now I can just mention, and before I say what I want to say, supervised learning involves training a model on a labeled data set. So this one is training a model on a labeled data set. Okay, which means each training example is paired an output label. For example, here, in linear regression model, that's an example we're going to use. Now, linear regression can be something like, let me see here, it can be something like predicting the house prices. We can use linear regression to predict the house pricing. Now, if I have a use case for this linear regression model, then it will be predicting continuous numerical values. And I have given an example of predicting the house pricing. Now, it models the relationship between what we call as the input variable. So I can write it here. The input variable and target variable. Let me write it correctly. And target variable. Okay, so the input variable here is a variable such as let's say a feature, while the target variable is now what is going to be our prediction. Okay, so this one is denoted as X, capital X, while this one is denoted as Y. Okay, now that is just an example of linear regression, theoretically speaking, but this linear regression does have some math behind it. Well, why so? Why do we say it has math behind it? Because it is a statistical model, and this model here is used to model the relationship between the input, which in this case is the independent variable, and a dependent variable. So the input here is the independent, while the output is the dependent variable. And on here, the relationship is assumed to be linear, meaning that change in independent variable, so the change in independent variable, okay, are associated with proportional change in dependent variable. So if I'm looking at the prices of the house and my independent variable, it could be one, it could be many. In this case, X will be the size of the house. So I'm using the house as an example here. So the smaller the size, the lower the price of the house. Okay, so Y is the dependent variable. The Y is an independent variable, or is a dependent variable, because it depends with the size of the house. And we are also assuming the bigger the size of the house, the larger the amount you will have to pay for that house. Okay, obviously it's not just one variable that decides how much the house it will cost, but we could have very many independent variables that determines how much the house could cost or should cost. For example, the location determines the value, the square feet, and also the features of that house. Okay, now I know we have used the equation y equals to mx plus c. Let me type it here as I've done it. Okay, this equation here represents a simple linear relationship between variables. The y here represents dependent variables, the x independent variables, the c is the y-intercept, while the m here represents the slope of the line. Now this equation here forms the basis of linear regression, a very fundamental tool used for predicting. So that marks the end of my video. See you again in my next video as we do prediction on the trends and many other. Thank you for watching. Bye.